let us do the next question, students. Question number 8. And this question number 8 is related to probability, right? We are being given with dice A and dice B. So the diagram shows two fair dice. Dice A is numbered 1, 2, 2, 2, 3, 6. And dice B is numbered 2, 3, 3, 4, 4, 4. So these are the numbers of each face of dice A and dice B. And then there are some questions that we need to solve. So we know the concept of probability, isn't it? Let us use it to solve this question. So here part A is part 1 says dice A is rolled once. Write down the probability that it lands on the number 6. Right? So first of all, let us see the number of favorable cases. How many number 6 face are there? There is only one, right? If we look at it, on dice A, we have only one face which has the number 6. And how many faces are there in total? There are total 6 faces. So the probability that the dice lands on number 6 would be 1 by 6, isn't it? So let us write it. Probability of getting a 6 is 1 upon 6, because this will, I'll just make it proper. There is only one favorable case and there are total 6 cases possible. So the probability of dice A when rolled and to get 6 is 1 by 6. I hope that part is clear. This was very easy, only 1 mark question. Let us move ahead. Next one. The sub part 2 of this is dice A is rolled 150 times. Find the number of times it is expected to land on the number 6. Guys, we already know the probability of getting 6. What is the probability of getting a 6? It is 1 by 6. And then how many times dice A is rolled? 150 times. So we will multiply the probability with 150 and the product will give us the probability of getting 6 when dice A is rolled 150 times. So let us write it down. Here it is going to be 1 by 6 multiplied with 150. So 6 is going to cancel it 25 times. So we get 25. So the answer for this is 25, because 6 cancels 150 25 times. So that is the answer for this one. That again is a really one-liner question, only 1 mark question. So that is answer being 25 here. Now guys, let us look at, there is a part B. Dice A and dice B are each rolled once. We have rolled dice A and dice B once. Find the probability that the two numbers they land on have a total of 6. Guys, we need to add the numbers that they land on and the sum should be 6. We have to find out that what is the probability of getting this sum. This question is of 3 marks, so we must be very careful that we need to show the relevant steps over here. Let us make some space for our working. What we'll do over here is, we will make a table wherein we will write the possibilities of the faces on which dice A and dice B will land, and we will add the sum, or we will get the sum of both the numbers. Let us do that quickly. For that I'll make a table. So here it is. Let me make it visible to you. Yep. And then we have also one more thing that I should write. Here it is. So when I talk about dice A, I'll write dice A here and dice B here. Okay guys, so dice A, what are the numbers on the faces of dice A? It's 1, then we have 2, another 2, one more 2, a 3 and a 6, isn't it? And when we talk about the faces, the numbers on the faces of dice B, we have a 2, then we have a 3, another 3, and then we have a 4, another 4 and one more 4. right? So let us find the sum of these numbers. So if dice A lands on 1 and dice B lands on 2, the sum is going to be 1 plus 2, that is 3. Similarly, 2 plus 2 gives us 4. 2 plus 2 gives again 4. 2 plus 2 is 4 again. 3 plus 2 is 5 and 6 plus 2 is 8. Right? Similarly, if dice A lands on 1 while dice B lands on 3, so 1 plus 3 is going to be 4. 2 plus 3 in the same manner would be 5. 2 plus 3 is again 5. 2 plus 3, that is again 5. 3 plus 3 is going to give us a 6, and 6 plus 3 is 9. Let us quickly do it for everything. 1 plus 3 would be 4. I guess this will repeat because it is going to be same. 2 plus 3 is 5. Then again 5, one more 5, then 3 plus 3 would be 6, and 6 plus 3 is 9, and 1 plus 4 would be 5, then 2 plus 4 is 6, 2 plus 4 is again 6, another 6, then 3 plus 4 is 7, and 6 plus 4 is 10. Moving ahead, we have another one, 1 plus 4 being 5 again, and then again it is going to be 6, 6, 6, 7, 10, because we are going to repeat everything. Then we have another 4, so it will be 5, 6, 6, 6, 7, 10. So what are the favorable cases, guys? We need the sum to be 6. So how many 6 do we have? Let us highlight them. We get a 6 over here, one more here, then we have some 6 over here. So if I count them, how many times are we getting the sum as 6? It is here as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the probability sum 3 or total 3, I should write. Probability of getting a total of 6 is equals to how many times are we getting 6? We are getting 11 times. And how many total possible sums are there? 1, 2, 3, 4, 5, 6. 6 in a row and 6 columns are there. So in total it is going to be 36. So what is the answer for this question? It is going to be 11 upon 36. I hope you are clear with this answer. How did we solve this? We have made a table wherein we have written down the number on the faces of both the dice, and then we are going to add the numbers, and then we will mark those numbers which are favorable for us. That is 6 in this case, and we are getting 6 as sum 11 times out of 36 times. That is what has resulted in the probability to be 11 by 36. So note it down for your reference. I hope it's clear. Let's move ahead. What is the next question, guys? The next question is, find the probability that when the two numbers they land on have a total of 6, both numbers are 3. Understand this question. The probability is about the sum of the numbers on the faces to be 6, right? It has to be 6. That we already have found. That how many times are we getting 6? 11 times. But another condition is that both the numbers on the faces of dice A and B should be 3. So when are we getting it? Here I see there is 3, and here we have 3 and one more 3. So we see that the cases when both the numbers are 3 is only 2. The number of cases 2 only, right? Out of how many? How many times are we getting 6? Again, I am repeating, please understand. The probability that when the two numbers they land on have a total of 6, how many times are we getting 6? 11 times. But also the numbers, both the numbers should be 3. So that is possible only 2 times. So the probability in this case is, here we will write it, number of favorable cases is equal to 2. Total number of cases is equals to 11. So this implies that the probability will be equal to 2 upon 11. That is what is our answer? 2 upon 11. Right, guys? Please note it down for your reference. We already have made that table. That table only we have used to get the answer for this question. Right? Let's move ahead. Do we have another question related to probability? Yes, there is part C now. Dice B is rolled n times. Now we are talking about dice B. It has been rolled n number of times. The probability that on the nth roll it first lands on a number 3 is 32 upon 729. Find the value of n. Let us first understand this question, guys. It's a very good question. We are being told that dice be rolled n number of times, out of which, out of those n number of times, on the nth time only, the dice B gave us the first 3. On the nth roll only, the nth time roll, we got the number 3 first time. That means before that we were getting all the numbers other than 3. Have you understood it? On the nth time only, it was the first time we got 3 as the face, top face. That means before that means how many times? N minus 1 number of times we were getting other numbers apart from 3. Right? So we need to find the value of n. That, what is the value of n? So if it is clear to you, let us try to solve it. Let us make some space. Now look at dice B. How many times do we have a 3 over there? We have 2 times 3 over there. So what is the probability of getting a 3? That is right. Probability of getting 3 is, how many times do we see 3 over there? 2 times. Because you can see the faces have the numbers 2, 3, 3, 4, 4, 4. So we are getting 3 2 times, and the total number, the total number possible cases here are 6, because total number of faces is 6. So 2 by 6 is actually 1 by 3. So probability of getting a 3 is 1 by 3. And as we know that on the nth roll only we got 3, so that means n minus 1 number of times we were getting other than 3. That is P not 3. What is the probability of not getting a 3? P not 3 would be what? It is going to be 1 minus 1 by 3, or I would write like this: 1 minus probability of getting 3. So it is going to be 1 minus 1 by 3. That will simply result into 2 by 3. So we got the probability of getting a 3 as well as not getting a 3. So let us try to write down in terms of an equation. The probability that on the nth roll it first lands on a number 3 is 32 upon 729. That means the probability of n minus 1 number of times not getting a 3 added with, so yes, we got the probability of not getting a 3. So now according to the condition, let us read the question. The probability that on the nth roll it first lands on a number 3 is 32 by 729. That means if I multiply the probability of not getting a 3, that is n minus 1 number of times, with the probability of getting a 3, that is only 1 time, is equal to 32 upon 729. That is what it is. So let us write now. According to the condition, we will write probability of not getting a 3, that is 2 by 3 raised to power n minus 1. Why? Because till n minus 1 number of times we were not getting 3, and then multiply it with that many number of times that we got 3, The probability of getting a 3 is 1 by 3 and we just got it only once, is equal to 32 upon 729. I hope this is clear. This is how it has to be done. Let us now quickly solve it. 2 by 3 raised to power n, and it is minus 1, so we can write it as upon 2 by 3 multiplied with 1 by 3 is equal to 32 upon 729. Let us further solve it. If we look at it, guys, it is 2 by 3 raised to power n minus 1. So we have, simply taken it away. What I see over here, that I can rewrite it as, since this is dividing it, so we can reciprocate it to multiply, right? So it is going to be 2 by 3 raised to power n multiplied with 3 by 2. It will become 3 by 2, and we already have a 1 by 3 to be multiplied, is equal to 32 upon 729. So what I see is that we can cancel this 3 with 3, and I will take 2 to the other side. So 2 by 3 raised to power n is equals to 2 goes there and will multiply 32 upon 729. So we get 2 by 3 raised to power n to be equal to 64 upon 729. So let us quickly get it. This 64 by 729, we can write it as the exponent of 2 and exponent of 3. We know that 2 raised to power 6 is 64 and also 3 raised to power 6 is 729. That is what we know about it. So we will write it as 2 by 3 raised to power n is actually equal to 2 by 3 raised to power 6. That means if both sides are equal, we will equate their exponents. So n comes out to be 6. This is our answer. The value of n, the desired value of n is 6. So this is how it has to be done. We are being done with this question. Please note it down for your reference. Next question, guys, now. That is question number 9. This question is about the differentiation. It will involve the concept of maximum point, and we also are being given with the graph of a function. Let us read this question. The diagram shows a sketch of the graph of y equals to 4x cube minus x raised to power 4. If I enlarge it for you, this question is this. We are being given with the graph of an equation. That equation is y is equal to 4x cube minus x raised to power 4. Right? That is what it is. I'll just make it clear. This is 4x cube minus x raised to power 4. I'll also write it over here. This graph is of y is equals to 4x cube minus x raised to power 4, right? This is the graph. Now the graph crosses the x-axis at the origin and at point A, and we can even visualize it in this graph, that this graph is crossing or touching the x-axis at 2 points. One point being the origin, that is O, and the other point is A. And we know that on x-axis the coordinate of y is going to be 0. So we will take care of that and we'll use it later on. Now, what else is given? The point B is a maximum point, guys. This point, and even we can see that this is the highest point where this graph reaches. So it is the maximum point. So what we need to do? We need to differentiate 4x cube minus x raised to power 4. Do we know the concept of differentiation? It's very easy. If I tell you, we know that if we have anything in the form of x raised to power n, like if I have y is equals to x raised to power n, what would be its differentiation? It is going to be dy by dx. Now the exponent becomes the coefficient or gets multiplied with the coefficient of the variable, and this x remains x, and the exponent we subtract 1 from it, right? So x raised to power n is differentiated like n x raised to power n minus 1. So we will use this concept to solve this equation and differentiate it. So what is being given to us? y is equals to 4x cube minus x raised to power 4. If we have to differentiate, we will write it as dy upon dx. We are differentiating this equation y in terms of x. So if I do so, what is the exponent of this variable? It's 3. So this 4 will remain as it is. 3 comes down, will be multiplied with 4, and then here we will subtract 1. So it is 4 times 3 x raised to power 3 minus 1 minus, and this x raised to power 4 will be 4 is here, and this is going to be 4 minus 1. So if we solve it, we are getting the dy by dx as 4 times 3 is 12 and 3 minus 1 is 2. So it is 12x square minus 4x, and its exponent is 4 minus 1, that is 3. So this is the required differentiation of this given equation. That is what we will write over here. Differentiation is 12x square minus 4x cube. What is this? This is dy upon dx, the differentiation of the equation y with respect to x. I hope this part is clear. This question was really easy. It involved only the basics of the differentiation. Let us move ahead. Now the next part is quite interesting. If we look at it, we need to find the coordinates of B. If we need to find the coordinates of B, we should have some reference, isn't it? But here we don't have any reference. The only thing that we know about point B is it's the maximum point of this graph. It's the maximum height the graph will achieve ever, right? So if it is the case, we know already that to find the maximum point or the maximum value of a given graph, we differentiate it and equate it with 0. When we equate the differentiated equation with 0, we will get the values of x. Those values of x are treated as critical points, and then we further solve it. We differentiate it one more time to see whether it's less than 0 or greater than 0, and then we come to know that whether it's maxima or minima, right? So here we need to first definitely differentiate this equation of y, which we already have done in the previous part. Let us equate it with 0 and get the points of x, and then we will further solve it. So if I write about it, let me just, yes, this is better. So now what is the equation? We know that equation is y is equals to 4x cube minus x raised to power 4, and we just got dy by dx as well. Dy by dx is 12x square minus 4x cube. So to find out the maximum point, we will have to equate this dy by dx with 0. So this implies that 12x square minus 4x cube is equals to 0. Let us quickly take out whatever we can as common. So I see that 4x square can be taken out common from both the terms. That leaves only 3 here, and this would be minus x equals to 0. So here we are getting the product of two things to be 0. So either this whole thing is 0 or this thing is 0. So we can say x is equals to 0 or 3 minus x is equals to 0, or I could write 4x square, that is again same thing. So we get it as x equals to 0, or if I transpose x over there, x is equals to 3. So we are getting these 2 points, and if we look at it, if I put x equals to 0 in the equation of the this graph, if I put x equals to 0 here, if I put x equals to 0 here, what we'll get? We will get 4 times 0 minus 0, that will be 0. So x equals to 0 comma y equals to 0 is actually what point? We know that it is the origin. This point is 0 comma 0. So this is not the maximum point. We know that maximum point is somewhere else. So for that maximum point, we will use the next point of x. So if I do so, what we are going to get? Let us check for x equals to 3. So if I put x equals to 3, I'll get the value of y. X equals to 3 means 4 times 3 cube minus 3 raised to power 4. Let us quickly solve it. 4 multiplied with 27 minus 3 raised to power 4 is nothing but 81. So 27 times 4 is 108 minus 81. So y comes out to be 27. So x equal to 3 comma y equals to 27. That is the coordinate of point B, isn't it? And if you look at it, it seems to be that only, that this point B is actually 3 comma 27. This is the coordinate of point B. Let us write that over here. The answer is 3 comma 27. Right? So I hope this part is also clear. We have used the differentiated equation and we equated it with 0. We got the values of x. We also then put it in the original equation of the graph and we got the corresponding value of y, and we get the maximum point B's coordinates as 3 comma 27. That's the answer for this part. Note it down for your reference and then we move ahead. Now it has one more part. Let's see, part C. Find the gradient of the graph at the point A. Very interesting point, guys. Gradient or slope, we know it is dy by dx, or differentiated equation. So if we get the value of dy by dx at point A, wherein we will definitely get some coordinates, so we will get the value of gradients, right? If I just show it to you in this way, that point A, we know that point A is on x-axis, so it will have some coordinate as x comma 0, because the y coordinate is going to be 0 over there. So if the y coordinate is 0, what should be done? We know that if we put y equals to 0 in the given equation, we will get the value of x. Let us find it out first of all. We know that the equation of this graph is y equals to 4x cube minus x raised to power 4. So we know that y is equals to 0. For y equals to 0, we will find out the corresponding values of x. So it is going to be 4x cube minus x raised to power 4 equals to 0, isn't it? So when we further solve it, we get x cube common, and we are left with 4 minus x equals to 0 over here. So this means x cube is equals to 0 or 4 minus x is equals to 0. So either x is equals to 0 or x is equal to 4. So if I talk about this x equals to 0, at x equals to 0, we are going to get this point, isn't it? X equals to 0 comma y equals to 0 is the origin. 0 comma 0, so it is not point A. So for point A, definitely it is going to be x equals to 4. So we are getting something like this, that the coordinates of point A are 4 comma 0. Let me change it over there for you. What are the coordinates of point A? Point A's coordinates are 4 comma 0, isn't it? So to find the gradient of this equation at point A, we need to put the value of x as 4 in the differentiated equation, or I should say for the dy by dx. So let us do that quickly as well. I'll just right, so let us find it out now. So here we see that dy by dx is actually going to be the gradient, isn't it? Dy by dx is the gradient. So gradient at point A, is x equals to 4, and let us substitute x equals to 4. So dy by dx for x equals to 4 would be, what is the equation of dy by dx? We know that was 12x square minus 4x cube. So 12 times x square, that is 4 square, minus 4 times x cube, that is going to be 4 cube. 4 square is 16. 16 times 12 is 192. Minus 4 cube is 4 cube is 64, and 64 times 4 is going to be, if I am not wrong, it is, let us find it out. Let us quickly find it out. It is going to be 64 times 4. 4 times 4 is 16. 4 times 6 is 24, and 1 25. So we are getting 256. And what would be the difference? 256 and 192. So 56 and 8 makes it 64. So we have minus 64. So what is the gradient at point A? It is minus 64. That is the answer for this question, guys. It's quite easy to find the gradient. If we have to find the gradient at any point, we need to get the coordinate of that point, and we substitute the x coordinate in the differentiated equation, and we will get the answer. So I hope this part is also clear. Note it down for your reference, and then we'll move to the next question. Now moving to the next question, question number 10. We are being given with a regular hexagon that is not to scale. The regular hexagon is ABCDEF, and we have to answer some questions provided DF, DA and DB are the diagonals of this given hexagon. Let us look into it. This is all about shapes and symmetry. The topic is all the types of different shapes. So if we again read the question, it says ABCDEF is a regular hexagon. A regular hexagon means a regular polygon is what? A regular polygon is the one whose all sides are equal to each other, and even their interior angles are equal to each other. So if we talk about regular triangle, that is an equilateral triangle, all the sides will be equal to each other and the angles will also be equal. If we talk about a regular quadrilateral, it is going to be a square because all the sides of squares are equal and all the angles are 90 degree in that. If we talk about a pentagon, an hexagon or heptagon, the regular ones would be having same length of side and same measure of their interior angles. So in this case, we are being given with a regular hexagon ABCDEF. The diagonals are DF, DA and DB, and we have to complete the following statements using 3 different triangles. Triangle DEF is congruent to triangle, which one we need to tell. If we analyze this figure, guys, first of all, let us analyze this figure. Here, what I see is this triangle DEF is under consideration, isn't it? Triangle DEF. So if I talk about this triangle, just by looking at the figure, which triangle do you think is going to be congruent to this one? If I look at the triangle DAF, it definitely seems to be of bigger size. So this should not be equal to or congruent to this one. If I talk about triangle DAB, that also seems to be not congruent to triangle DEF. That leaves one last triangle, that is triangle DCB. Do you think is it congruent to triangle DEF? Let us figure it out. Let us try to find out the answer for this. If I talk about these two triangles, let us first make some space for our working, and let me explain it to you how come I think that triangle DEF is congruent to triangle DCB. Let us look into those triangles first of all. So in triangle DEF and triangle DCB, what we see, guys, we know that the angles of the this given hexagon are going to be equal to each other. That means this angle is definitely equal to this one, isn't it? We know that the regular hexagon will have all the interior angles to be equal to each other. So angle DEF is definitely equal to angle DCB, and also this side DE is equal to DC, while EF is definitely equal to CB. So let us use this first of all. In triangle DEF and DCB, we are being given that DE, the side DE is equal to side DC of the other triangle, and we talk about the angle angle DEF is equal to angle DCB. What are the reasons? Let us also mention the reason. Equal sides of a regular polygon, isn't it? And here equal angles of a regular polygon, isn't it, guys? And again, when we come back to this last, is EF is equal to CB, so that makes it equal sides of the regular polygon. Right? So if we talk about this relation, we find out that by the criteria of side angle, these two triangles are congruent to each other. We will write this implies that triangle DEF is congruent to triangle DCB. By what criteria? By side angle side criteria. Isn't it, guys? So we just have proved that triangle DEF is actually congruent to triangle DCB. Let us write it here. This is the first answer. I hope you are clear. Moving ahead, we have to again tell that there are two more triangles which happen to be congruent to each other. So if I talk about, we see that only triangle DAF and DAB are left. So are they congruent to each other? To check it, let us look at it. Let us just write one more thing. As we know that triangle DEF is congruent to triangle DCB, that also implies that this side is equal to this one, isn't it? By corresponding parts of congruent triangles, we know the corresponding sides are going to be equal to each other as well. So that tells us that DF is equal to DB. For that we can write corresponding parts of congruent triangles. Okay, the corresponding parts are these. So this we will take as a reference point to prove that triangle DAF and DAB are congruent to each other. For that I am also marking, that this AF is going to be equal to AB, being the sides of a regular hexagon. So let us use it now. Now it is going to be this one. Now in triangle DAF and triangle DAB, what we see, first of all, you can think that DA is equal to DA, being the common side, isn't it? DA is equal to DA, that's the common side of both the triangles, followed by AF is equals to AB. These are the equal sides of a regular polygon, isn't it? And the last one is, we just have proved that DF is equal to DB, proved above, isn't it? So we just have proved that the three sides of this triangle DAF are equal to the three corresponding sides of the triangle DAB. That makes these two triangles to be congruent to each other. So we can write that triangle DAF is congruent to triangle DAB, isn't it? By what? By SSS, that is side criteria or congruency criteria. right? So the answer for this would be triangle DAF is congruent to triangle DAB. Right, guys, this is the answer for this question. This was an interesting one. We have used the concept of the regular polygons as well as the concept of the congruency of triangles. Note it down for a reference. This solution is very important to get to the answer, and we should always mention the relevant steps. Moving ahead, we have another question related to shapes, and we are being given with a circle with center O, and we see that there are two tangents from point P and Q of the same circle meeting externally at point T, and we have joined the center of the circle with that point of meeting of these two tangents, not chords. So this OT is also there. So let us read it properly. P and Q are points on the circle with center O. We are being given that P and Q are the points on the boundary of the circle with center O. That is clear. Now TP and TQ are tangents to the circle drawn from point T. So if we talk about, this is the point P, external point P, and we have drawn TP and TQ as two tangents on this circle. Complete the following statements and reasons. In triangles OPT and OQT, let us first of all analyze OPT and OQT. We have to find out OP is equal to what, because each is a radius of the circle. If I talk about, guys, this O being the center, so this AP is the line segment which joins the center of the circle with a point on the boundary of the circle. So this is definitely going to be its radius. And similarly, Q is also a point on the boundary of the circle, and it is getting joined with O. So OQ also becomes the radius, isn't it, guys? So the answer for this would be OP is equal to OQ, because each is a radius of the given circle. That is quite easy. Just by analyzing the figure, we can get the answer. Moving ahead, OT is a common side. Yes, definitely OT is a common side. We are just talking about the triangles OPT and OQT, right? Let me just mark it with red for your reference. We are talking about the triangle OPT and triangle, I'll mark it with green, the other triangle is OQT. So definitely we see that OT is the common side, isn't it? OT is the common side for both the triangles. So now angle OPT is equal to angle, we have to find out which angle, and that is equal to 90 degree because, so let us first analyze that as well. OPT, angle OPT is 90 degree. We are being given, look, OPT is equal to 90 degree. Why? What is the reason? Do we know any reason? Yes, we know that the angle formed by the radius and the tangent at the point of contact is always 90 degree, or I should say radius is perpendicular to the tangent at the point of contact. So definitely it is going to be 90 degree. So that must also be followed for the other tangent and the radius, isn't it? OQ being the radius and TQ is the tangent at that point of contact. So this angle must also be 90 degree, isn't it, guys? Because that also is going to be the reason, the same reason. So let us write the answer for this. Angle OPT is equal to angle OQT, which is equal to 90 degree because what is the reason? Radius is perpendicular to tangent at point of contact. That is the reason, isn't it? The radius is perpendicular to the tangent at the point of contact. That's why that is also 90 degree. So now triangles OPT and OQT are congruent using the criteria. What criteria have we used? Let us look at it. If I talk about the criteria, we have taken 90 degree. That means it's right angle. We have taken the hypotenuse of both the triangles, that is OT. How come I am sure that OT is the hypotenuse? Because we know hypotenuse of a right triangle is opposite to the 90 degree angle. So if we talk about this is 90 degree angle, so opposite to it is OT, and for this triangle also the opposite side is OT. So OT being the common hypotenuse, so we have used right angle and hypotenuse, and we have then used one more side, that is this one. So what criteria have we used, guys? Yes, you have figured it out correctly. The criteria used over here is RHS, that is right angle, hypotenuse, side. Okay, then moving ahead, this proves that the tangents TP and TQ are, first of all, we know by the corresponding parts of the congruent triangle that the remaining sides and the remaining angles are also going to be equal to each other. So this tells us that this TP is equal to TQ, and they also happen to be the tangent. So we will write R equal. Isn't it, guys? So for writing the correct reasons and the correct values, you are going to get total 5 marks for this. I am just erasing it a little bit and writing it one more time so that you might not get confused. This was RHS criteria, and there we should write, because radius and tangent are perpendicular at the point of contact, right? So these are the reasons. OP is equal to OQ because each is the radius of the circle. OPT, angle OPT is equal to angle OQT. OT is the common side, and that the reason behind these angles to be equal is 90 degree, because the radius and tangent are perpendicular to each other at the point of contact. So that means the triangle OPT and OQT are congruent to each other by the criteria of right angle, hypotenuse and side, and also that makes the tangents TP and TQ to be equal to each other. So we are done this with with this part of the question. Let us move ahead after you finish it, right?